see the news and wonder why a huge earthquake can hit one place and cause relatively little damage, but then a much weaker one just completely devastates another? Well, it's not just about the raw power of nature. There's actually an equation at play here, a mix of physical force and, this is the important part, a critical human element. That's what decides if a tectonic hazard becomes a full-blown catastrophe. So let's dive in and unpack this tectonic disaster equation.
Okay, so here's the puzzle that gets right to the heart of what we're talking about. I mean, a 9.0 magnitude earthquake is literally hundreds of times more powerful than a 7.0. So how on earth could the weaker one end up being so much deadlier? This isn't some riddle, it's a real-world comparison that basically reveals everything.
And here are the numbers. This is just such a stark contrast. Over on the left, you've got Haiti in 2010, a magnitude 7.0. The result? An absolutely tragic 220,000 lives lost. Then, on the right, Japan in 2011, a monster 9.0 quake. And yet, the death toll, while still awful, was around 20,000. The biggest difference isn't the number on the Richter scale. It's that level of development. And that's our first major clue right there.
Right, so to solve this whole thing, we first have to look at one half of the equation, the actual physical power of the hazard. We can't just ignore the raw energy that the planet itself unleashes. So what are we actually talking about when we say physical factors? Well, they're basically the natural ingredients of the event. Think of it like nature's stat sheet for a disaster, just the pure geophysical facts of what happened before any people get involved.
Let's break those down a bit. Magnitude, that's the one we all hear about, right? The total energy released. But depth is just as crucial. A really shallow earthquake, even if it has a lower magnitude, can feel way more violent on the surface. And of course, location, location, location. An earthquake in the middle of a desert is just a geological event. But that same quake under a huge city? That's a potential catastrophe. Even the dirt beneath your feet matters. Soft soil can actually amplify the shaking and make everything so much worse. But like we saw with Haiti and Japan, that physical power, that's only half the story. So let's flip over to the other side of the equation, the variable that really truly changes the outcome. Us, the human factor. And this is the most important point. The earthquake, the volcano, the tsunami, they're just the trigger. The scale of the disaster that follows, that story is almost entirely written by us, by the societies we've built. So human factors is really all about a community's resilience. How strong are their buildings? How effective is their government? How well can they prepare for and respond to a crisis? It's basically a society's immune system against a natural threat. And we can really boil all of this down to three essential areas. First up, a country's economic development. That decides what kind of resources they even have. Next is the quality of their governance, which determines how well those resources are actually used. And finally, you've got the level of preparedness and infrastructure that comes out of those first two.
Theory is great and all, but the proof is written on the ground, in the real world. So let's see how these human factors play out by comparing a few different events.
And wow, this table just lays it all out, doesn't it? We've talked about Haiti and Japan. Now let's add Chile in 2010 to the mix. A massive 8.8 magnitude quake, way stronger than Haiti's. But just look at the fatalities, around 500. 500. Why? Because Chile, just like Japan, had strict, enforced building codes and a real culture of preparedness. Haiti, on the other hand, facing incredible economic and political hurdles, had neither. This slide just shows it, plain as day. Good governance and economic stability can save hundreds of thousands of lives. Let's just zero in on that idea of governance for a second, because sometimes it isn't even about expensive buildings, it's about simple communication and just taking action. And the failure to do that, well, it can be absolutely catastrophic. Take a look at this number, 23,000. This isn't from an earthquake, it's from a volcanic eruption where the science was crystal clear, the warnings were there, and yet, this was the result. This was the tragedy of Armero, Colombia. For weeks, scientists had warned about the risk of these massive volcanic mud flows from the Nevado do Ruiz volcano. But because of a total breakdown in communication and official inaction, those warnings never led to an evacuation. When the eruption finally triggered the mud flows, the town was just wiped out. This wasn't a failure of science. It was a catastrophic failure of governance. All right, so let's put all these pieces together. How do we get from a simple geologic event to a massive human disaster? This sentence right here just perfectly sums it all up. A hazard, that's just a force of nature. The disaster part only happens when that force slams into a human population that is too vulnerable to withstand it. You could say the hazard is the spark, but human vulnerability, that's the fuel.
So it really boils down to this simple but incredibly powerful three-step process. First, an inevitable natural hazard happens. That's just our planet being a planet. Step 2 is the crucial intersection, when that hazard meets a vulnerable population. And that right there is what leads directly to Step 3, a full-blown disaster, where a community's ability to cope is just completely overwhelmed.
And that kind of brings us to the final thought here. It's really easy to look at these massive events from far away, but the same principles apply everywhere, to everyone. So I'll just leave you with this question to think about. What are the human factors at play where you live? What makes your own community resilient or vulnerable to the hazards it might face?